Hello, my name is Amanda Pennington, and we're going to be going over Module 5 written exam. So, question 1 says, write the decimals as fractions in the lowest terms and determine the prime factorization of the denominator in each case. So, A is 0.225. And it's important to notice that this comes at the end of the thousandths place. We have tenths, hundreds, and thousands. So step 1 is we're going to multiply it by 1,000, getting 225. Then we're going to divide it by 1,000, making a fraction of 225 over 1,000. So we need to get it in the lowest form of the fraction. So we're going to divide by something that can go into both 225 and 1,000. So we're going to divide by 25. 225 divided by 25 is 9, and 1,000 divided by 25 is 40. And that is the lowest terms it can go into, 940. Now we got to find the prime factorization of the denominator, which is 40. So we're going to make a factor tree. 80 and 5 equal 40. So 5's prime, so we circle it, and we have 8, and that can go into 2 and 4, and so we circle those. So 2 exponent 1 times 4 exponent 1 times 5 exponent 1 is the answer for the prime factorization. So now we're going to go into question 1b. 0.0 decimal 0.36, and that is in the thousands place still as well. So we're going to times it by 1,000, giving us 36. Then to make it into fraction, we're going to divide by 1,000. 36 divided by 1,000. Then we're going to divide it by 4 so we can get it into the lowest fraction form. 36 divided by 4 is 9. 1,000 divided by 4 is 250. And that's the lowest form of the fraction because 9 is divisible by 3, but 250 cannot go into 3. So now we got to do the prime factorization of 250. We're going to use a factor tree, and it shows that 250 can be divided by 5 and 50. 5 is prime, so we circle it. 50 can be broken down to 5 and 10, circle the 5, and then 10 can be broken down into 2 and 5, and those are prime. So since 2 is the lowest number, that goes first, 2, and there's only 1, so the exponent's 1, times 5, since we have 1, 2, 3, 5, we have exponent of 3. And that's the prime factorization. Now we have question 2. Create a graph for each formula and make up a reason for the shape of the graph. Make reasons 1 or 2 sentences each. So the first one we have y equals x over 2. And so we're going to use the formula y equals mx plus b. M is the slope and y is the b is the y-intercept. So since there is no b, we're going to add it and make it a 0. So then for step 2, we're substituting x for numbers. So we're going to substitute x for 1. So we have 1/2 plus 0. So the 1 becomes the coordinate x, and the 1/2 becomes the coordinate y. Then we're going to substitute it for 2. So 2 over 2 is equal to 1 whole, so that'll be 1, so it'll be 2, 1. Then we're going to substitute it for 3, and that would be 3 over 2 plus 0, so 1.5. And so we have 3 and 1.5 as a coordinate. And so now we're going to graph those. And the reason why we graph them 1/2 for 1 and so on is because x, this is the x-axis and this is y. The reason they're in this quadrant is because both x and y coordinates for the numbers are positive, so they're going to be in this quadrant. And so that is when the line will go this way, going upwards. The line on the graph is directed this way because the coordinates are all positive, so they will belong in the particular coordinate. Okay, now we have 2b. Y equals negative x over 2. And so it's the same thing as we just did. We're going to use the y equals mx plus b form. We're going to plug in the x's. And so with it being negative, all of our y's are going to be negative and all of our x's are going to be positive. And so when we look at it, we get the same coordinates besides with it negative. So 1 for the x and negative 1/2. We get 2 and negative 1 and 3 and negative 1.5. So what that does, that actually flips it over the x-axis because we have negative and a positive. Because our positive numbers are our x's, so it's going to remain on this line, and our y's are negative, so that's what makes it in that quadrant area. And now we're going to go on to 2c, y equals 10x. So we're still going to use the formula y equals mx plus b. And we're going to add that 0. So we're going to start off with the quadrant or the coordinate 0, 0. And we're going to plug in 1 for x. So 10, 1, that will be 10. So we have 1, 10. And so we're going to use those two coordinates to plot our graph. And it goes up almost directly onto the y-axis because we got our first coordinate, which is 0, 0. And then it's just one hop over and up 10. So it's that close, but they're still positive. So that's why it's in that quadrant. All the numbers are positive for x and y. Next, we are going to move to 2D, which is y equals x exponent 2. So we know that this graph will have a parabol. We will use the vertex formula y equals a parentheses x minus h parentheses squared plus x. And so we know that our a is equal to 1. Right now our h is equal to 0 and our k is equal to 0. So first we need to find the vertex, which is the parentheses coordinates of h and k. And that's going to be 0, 0. Now we need to find the distance from the vertex using the formula 1 over 4a. Now we know that a is going to be equal to 1. So 1 over 4 times 1. And so we're going to X those out, 1s and 1s, and that gives us still 1/4. So we're going to need that for later. Now let's find the focus of the parabol by h, comma, k plus p, parentheses. So we know that h is 0, k is 0, and the p is going to be our 1/4 that we just got. And that gives us a coordinate of 0, 1/4. Now we need to find the directrix of y equals k minus p, and that is y equals 0 minus 1/4, giving us 1/4, negative 1/4. Now we have our information. We know that the parabol will open up. The vertex is 0, 0 coordinate. The focus coordinate is 0 and 1/4. The axis of symmetry is x equals 0. That's very important. And the directrix equals negative 1/4. So now we're going to plug in for x, giving us coordinates. We're going to start off with negative 1. Negative 1 times negative 1 is going to be a positive. So we'll get that number. And we plug these in, and we got coordinates negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So now we're going to plot those. And this is what it looks like. So this is our x-axis right here, and this is our y. With this, we got our 0, 0, which is our axis of symmetry. That means it's going to be right in the middle. Then we have our 1, 1, and our negative 1, 1. And then we have our 2, 4, and our negative 2, 4. And the reason why it's up here is because our y coordinates are positive, and so that's why it's going to be going straight up this way. The axis of symmetry basically is flipping over the y. So whatever is positive, it flips over to the negative point of that. Now let's go on to 3. What percentage and fraction of each figure is red? So right now, this is the first figure we have is our square. And we know that this triangle right here can be evenly broken into another one, into 2. So that's what we're going to do. So this new one on the right shows us that there are 8 equal pieces of the triangle in the square. So that 8 is going to be our denominator. And the one shaded piece of triangle is going to be our numerator. So that gives us a fraction of 1/8. To get a percentage, we need to take the fraction into a decimal by dividing the numerator and the denominator. So 1 divided by 8 equals 0.125. Then we need to take the decimal from step 2, which is our 0.125, and multiply it by 10. And that gives us 12.5, which is now our percentage of 12.5% of the one triangle piece of our square. Now let's solve for this one. So this is a square made up of smaller squares, but there is one small triangle that is divided into 2 and 1 square. So that tells us that we know that 2 triangles fit into 1 small square. So we're going to break that down. And so we're going to get 2, 4, 6, 8, 10, 12, 14, 16, and 18 pieces of triangles. And the shaded red portions become 2, 4, 6, 7. So we get a fraction of 7/18. And so now we're going to take step 2, fraction of 7/18, and divide it by 7 divided by 18 to get a decimal, which is our 0.3888. And that line over the 8s means it's a continuous 8, that it's never ending. So we got to take that 0.3888 that's never ending and times it by 100. And that gives us 38.88 with that line over the 8s again because it's never ending. And that gives us our percentage of 38.88%. Now this one's a little bit easier. This is our circle that we're going to look at. And we know from looking at it that there are 2 equal pieces. We can't break that down anymore. It's already done for us. So we know if we have 2 pieces and one is shaded, that gives us 1/2 of a fraction. And when we take that and divide it by 1 divided by 2, that gives us 0.50 as a decimal. And so we're going to times that by 100 to get our percent, which is 50%. Now question 4. If the area of the yellow hexagon is whole, then the remaining pattern blocks have areas that are approximately 16.67%, 19.2%, 33.3%, 38.5%, and 50%. So the pattern blocks the percentage to the hexagon. So what we're going to do for step 1 is that we know that the smallest percentage that there is 16.7, and so that's going to belong to the smallest shape that there is to compare it to the hexagon, which is going to be our triangle. So that makes the triangle 16.6% of the hexagon. And then we know that one hexagon can be equally divided into 2 trapezoids, which is our red trapezoid right here. And so we're going to make that out of a fraction of 1/2 or 50%. And so that 50% is going to go to the red trapezoid. Next, we have 19.2%, 33.3%, and 38.5% left to find. If we take 33.3% and divide it by 100 to receive a decimal, then we can convert decimal into a fraction. So here's the work: 33.3% divided by 100 equals 0.333, or it's equivalent to a fraction of 1/3. So we know that a rhombus, which is this one right here, the blue rhombus up at the top, can fit into the hexagon 3 equal times. That means that it's equally divided into it 3 times. So that's gonna say that the blue rhombus is the 33.3%. Now what we have left is 19.2% and 38.5% left. And we have shapes of purple rhombus and the pink square. And we know that that square is larger than the purple rhombus, making the square the larger percentage of the 38.5% and the purple rhombus 19.2%. So the total percentage of the shapes of the hexagon is triangle is 16.67%, the red trapezoid is 50%, the blue rhombus is 33.3%, the purple rhombus is 19.2%, and the square is 38.5%. Now let's move on to question 4, or question 5, my bad. There are 3 common types of percentage problems. 1, given A and B, what percent P of B is A? Question 2, given A percent P in the whole B, what is A if it is P percent of B? And given a part A that is percent of the whole B, what is the whole B? This is design a classroom poster that gives a realistic problem and its solution for each of these percentage problems. Your poster and a problem should be unique and made up with something that relates to your life. So something that relates to my life is that I have tons of nieces and nephews of all ages. And they like to share and play with each other with the toys that they have. And so that's what we're going to look at. Okay, so this is going to be 5-1. Given A and B, what percent P of B is A? And this is at the top of the poster. And then we have a little example for Leanne. Leanne loves bookmarks. So we put Leanne has 4 National Geographic animal bookmarks. She gives 2 bookmarks to Kathy. And so to visually understand it, my bad. What blank of these are the 4 bookmarks that she have equals these 2 bookmarks. And we know that 2 is half of 4, or 2 over 4, and we can turn that into a decimal by 2 divided by 4 equals 0.50 times 100 equals 50%. And that means that Leanne gives 50% of her National Geographic bookmarks to her friend Kathy. So that means that she gave her the blue whale and the tortoise. Okay. Oh, sorry. This is question 2. Giving a percent P in the whole B, what is A if it is P percent of B? And that's at the top of the poster. And Andrew has 4 race cars. He gives 25% of his race cars to his brother Talon. How many of Andrew's race cars did he give away? So 25% of the 4 race cars equals what? And I went ahead and drew in 1. And that's because we know that we can write 4 over 4 to show Andrew's race cars. We also know that we can write the fractions into decimal. So 1/4, that means 1 of his cars out of all 4 of them is 0.25. 2 of them is 2 over 4.50, 3 over 4 is 0.75, and 4 over 4 equals 1 whole. So we know that 1/4 gives a decimal of 0.25, which is also 25% when multiplied by 100. Making 1 race car that was given away. And this is our 5-3. At the top of the poster it says, given a part of A that is a P% of the whole B, what is the whole B? Lexi gave 75% of her Shopkins to a friend. Her friend receives 3 Shopkins. How many Shopkins did Lexi start with? So we know that 3 Shopkins equals 75% of Lexi's Shopkins. Okay, so we need to know how many she started with. We know that 75% can be written as a fraction of 3/4. So to make that fraction whole, we need 1/4 added, which means 1 more Shopkin makes 4 Shopkins Lexi started with. So Lexi started with 4 Shopkins and gave 3 of them away. And then we are going to do question 6. It says, create a proportional reasoning scenario, then create a table and a graph to show the rate of your proportional change. So I put Amanda is making red velvet cupcakes for 24 people. Her recipe makes enough for 12 people. How can Amanda make enough for 24 people? So we know with our recipe that's down here, our original recipe, she has 1 cup of flour, 1 teaspoon baking powder, a half a teaspoon salt, half cup of butter, 1 cup sugar, 2 large eggs, and 2 teaspoons vanilla. So to get to 12 to 24, we know that 12 times 2 equals 24. So that means we need to double all of our ingredients. So this is what we're going to do. 1 cup of flour times 2 equals 2 cups of flour. 1 teaspoon baking powder times 2 equals 2 teaspoons baking powder. 1/2 teaspoon salt times 2. 1/2 plus 1/2 equals 1 whole teaspoon salt. 1/2 cup of butter times 2 equals 1/2 plus 1/2, which is the 1 whole cup of butter. 1 cup of sugar times 2 equals 2 cups of eggs. We have 2 large eggs times 2, so that means we have 4 large eggs needed. We have 2 teaspoons vanilla times 2, and that gives us 4 teaspoons vanilla. So this is going to show us our new recipe compared to our old recipe in a table. So here's our ingredients. So in our original recipe, we had 1 cup of flour. And in our new recipe, we have 2 cups of flour needed. In our original recipe, we had 1 teaspoon baking powder. In our new recipe, we have 2. In our original recipe, we had 1/2 teaspoon salt. Now we have 1 teaspoon salt. Our original recipe, we had about 1/2 cup of butter. Now we have a whole one. We had 1 cup of sugar. Now we have 2. We originally started with 2 eggs, and now we have 4 large eggs. Then we had originally 2 teaspoons vanilla. Now we have 4 teaspoons of vanilla we need to do to make the 24 servings. Now this is a graph just showing how we proportionally increased our amounts. So over here, this is going to be the amounts of ingredients that we are going to use. And down below shows each ingredient. So we can visually see that we doubled our cup of flour, we doubled our teaspoon, and we see the big growth in each of these. Using a recipe that serves 12 people, Amanda had to double the recipe to serve 24 people. Taking each ingredient and multiplying by 2 to double that answer was the new amount for that ingredient. Making a table showing the original recipe amount and new recipe amount, you saw the proportional change. Then with the bar graph having the original recipe amount in blue and the new recipe in red-orange, you visually saw the increase of proportions to serve 24 people. So that is the end of Module 5 written exam. I hope you have a blessed day and have a wonderful evening. Thank you for watching.